Hello students, I'm Dr. Sumit Majumdar. I'm a pass out of IIT Delhi. I'm from the 2003 batch and since then I am with askIITians. So today we'll be discussing about kinematics. Kinematics is the branch of physics wherein we understand about how the objects move. What basically is understood by motion. So basically when an object starts from a particular point and moves to any other point, then how much is the path that is traversed by the particle? What are the equations that govern the laws? That is, we'll try to understand about the equations of motion, how that has been derived. Then we'll also try to understand about what are the uniform motion and uniformly accelerated motion. So to start with, we'll be discussing about the rectilinear motion in uniform motion. Thank you. Now, we'll be starting off with the first topic in kinematics. So what we talk about in kinematics, let's try to understand about that. So kinematics, when we talk about kinematics, this is nothing but the study of the geometry of motion. What does geometry of motion means? How does any object move? What exactly is the value of displacement? How much is the velocity produced? How much is the acceleration? And obviously how much has been the time taken. The time obviously needs to start as to from when the motion is actually starting off. This is slightly different, that is kinematics is slightly different as compared to kinetics. Kinetics is nothing but the study of relations that exist between forces which act on a body, the mass of the body and the motion of the body. So here the mass is important, whereas in the case of kinematics, mass was not important. It was studying the geometry of motion. Right? So kinetics is used to predict the motion that is caused by given forces or to determine the forces which are required to produce a given amount of motion. Okay. Going further, we can differentiate the kinematics part into two basic parts. That is, one is known as a rectilinear motion, the other one is known as a curvilinear motion. Right? So when we talk about a curvilinear motion, so in this kind of a curvilinear motion, what exactly happens? In this case, the position, velocity and acceleration of the particle as it moves along a curved line is changing, whereas in the case of a rectilinear motion, it is going to be equals to different things. There is going to be position, velocity, acceleration of particle as it moves along a straight line. In this case, it is moving in 2 or 3 dimensions, mind you, not along the straight line. So there, at any instant of time, there are going to be two components of the vector values that are there that are going to be present. For example, the position can have 2 components, the velocity will have 2 components, acceleration will have 2 components, and so on. That is how the curvilinear motion actually works. Hopefully that makes sense. Going further, what will we say if I have to talk about the rectilinear motion? So in the case of rectilinear motion, the particle moving along a straight line, that is what is known as a rectilinear or a linear motion. In this case, the position coordinate of a particle is defined either by a positive or negative distance of the particle from a fixed origin. You need to choose whether the particle is along the positive direction or it is along the negative direction. So if it is along the negative direction, obviously it's going to be negatively placed. If the magnitude will be positive, but the point is going to be negatively placed, whereas at the point P is going to be positively placed. Further, if I have to say, the motion of a particle is known if the position coordinate effectively is known. So if the position coordinate is known for every value of time t, in that case we can write down or we can express the position as a function of t like this. The x varies like t square minus t cube, so that can be plotted out here. So this is the graph that we have for this. Hopefully it is clear. Now, if we go further and try to define what are the different kind of things. So in this case, what will we have? We'll say that if we consider any particular particle, let's say which is starting from this particular point P, O, and at any instant of time it is occupying this position P. After some instant of time, likely if we increase it, it occupies a new position P prime. Therefore, how will you find out the average velocity? So average velocity will be equal to the total distance that it has covered in this particular time interval, that is between t and t plus delta t. So that is what is known as delta x by delta t. If I have to talk about the instantaneous value of velocity, so instantaneous value can be at any given point. So we just try to put delta t approaching 0. So under the limit delta t approaching 0, that is, there is no change in time. So under that circumstance, how much is the change in the value of delta x? That is what we find in the case of instantaneous value of velocity, right? So if I say that this is the instantaneous value of velocity, so the instantaneous value of velocity may be either positive or it can be negative. Magnitude is going to be known as the particle speed, because that is the speed with which the particle is actually moving. Okay, now if you remember, we defined the displacement of the particle as 6t square minus t cube. So the instantaneous speed, you can say, or velocity, is going to be equals to dx by dt. So under the limit delta t equals to 0, you will get dx by dt. So if you just differentiate, you will get 12t from the first term and minus 3t square from the second term. So that is from the definition of the derivative. In a similar way, we can say that the instantaneous value or instantaneous value of acceleration can either be positive or negative. But even in the positive case, it can be done by increasing positive velocity. That is, increasing positive velocity means you are moving along a positive direction of velocity, so that gives you the increasing positive velocity. Or decreasing negative velocity. Decreasing negative velocity means you are moving along a negative direction with a velocity that is decreasing in magnitude. So in either of the cases, the instantaneous acceleration is going to be positive. In the other case, for example, if the instantaneous value of acceleration is negative, then you can have either by decreasing positive value of velocity or increasing the negative value of velocity. In either of these cases, you will get a instantaneous value of acceleration which being negative. So if I say that the acceleration is given by this particular relation, that is the second derivative of x with time square, you know that the velocity is given by this, therefore the acceleration is going to be given by the second derivative. So this is how we find it. Again, coming back, if I say that this is how the particle relation has been given. So if the particle relation has been given by this, so this, if you look at it, and say that this is the expression of the graph of the displacement, right? So if this is the expression of the graph of the displacement, in that case, what we'll say here, so this one is nothing but the expression of the velocity. So how the velocity is changing with time given by this particular relation. Again, it's a non-linear graph, that's the reason you have a negatively sloping graph. And the acceleration. So for the case of acceleration, what will we have? For the case of acceleration, as you can see, it is a negatively sloping graph, but it is a linear graph, right? So it has to be linear in that sense that this does not change with slope, or there is no change in the slope taking place. The acceleration is constant in this case. So if the acceleration is constant, so for time t equals to 0, it will come up with this. Time t equals to 2, x equals to this, and the velocity is 12 meters per second. At time t equals to 4, acceleration comes out to be negative, and similarly at time t equals to 6, it's going to be equal to 24 meters per second square. So if you just plot it, it's going to be coming out uniformly sloped.
So students, we learnt about how a body moves in a uniform motion. What exactly was rectilinear motion? So rectilinear motion basically tells us about when the body moves in a straight path. That is what is meant by rectilinear motion. We also understood about the very basic introducing concepts, that is speed, velocity, acceleration, displacement, distance, time. So these are the quantities that are going to govern further things. We'll take it further and try to understand about the next topic in our next forthcoming lecture.